Good morning, everybody. Yes, Gamal Nasser is asking, is the session is on? Yes, we just started. Good morning, everybody, and this is Dr. Mansour with the Professional Engineering Services and Education. And today is Sunday, the 14th of May, 2023. And this is the last session of the transportation PMCBT. For the spring 2023. I'm going to start very soon the new prep courses next Sunday, Saturday and Sunday, in fact. I'm going to start the new round of courses with the new books that I'm trying to get them in-house here as soon as possible. Let me see if it is the brochure is still available or not. I believe it was available yesterday. And this one here, yeah. So this is a new set of courses that I'm going to offer with the new books. Transportation specifically, I still have my 3 books. This is a transportation here. It is 65 hours or more than that. No, 75 this time, 75. So the most comprehensive course available in the market, as far as I know, there is no such course can match this number of hours. And the 3 books that I had before, I improved them and tried to match the NCEES 1.2 and enhance and improve. And this will start next Sunday, I believe the Sunday, the 21st, that's correct. And I will start have some workshops on Mondays. Okay, so I did not generate the ID yet. For those who are already enrolled in the class, you will receive the ID where you can enroll only one time, and this will be sufficient for the entire course. It will start May and it will end physically. The exam, the practice exam, will be on August the 8th, but July 30th is the last day of the class, including all the workshops. I have 6 workshops and I have all these things, and I will do my best. In addition to the 3 books that I authored, these are the 5th edition, by the way, the 5th edition. Yeah, the 5th edition. This is a new one. And I try to take care of anything that indicated to me by you or by your fellow engineers. The books has been rated very high on Amazon, and I'm trying to always improve, continuous improvement, as all of us know. In addition to the 3 books, I have normally I send this, which is the NCEES handbook 1.2, the new one, and obviously the practice exam, the 80 problems for the transportation, the white book. Okay. Last time we were talking about chapter 5, traffic signals. This is my book. This is the 4th edition, and the 5th edition, as I said, is coming, okay, very, very soon. But I received an email yesterday from one fellow engineer. Let me share it with you very quick. You might benefit from that. He took the class and he passed and he is happy. So I saw this email this morning. I said, let me share it with you. And you may benefit from whatever he suggests. He said, Dr. Mansour, I would like to convey my appreciation to you, okay, and the course material provided. My BE journey has been, okay, fruitful ending. It took a little bit longer than due to family and work and so on. I still remember your advice to prepare very well before, okay, heading to the test, which I did. You have to prepare extremely very well. He put very well bold face here. Normally, I tell everybody minimum 500 hours, okay, for the AM and the PM. Sit and study and the PM. It doesn't matter which course or which study material you have. You need to sit and study and do your best. And I believe, I know probably too many hours I ask here for, but this is what I believe, and it depends really on. I know it is a long journey, and you have to spend the time, but this is what I recommended. Okay, if you cannot afford the 300, 500 hours, you may drop it to 400 or 300, but you have to focus very well and understand the concept. I said that that honestly, okay, your course covers 80 to 90% of the exam. The books you supplied, okay, prepared a key of the access of okay. Haven't I have I haven't tried other BE courses provided, okay, but I believe the way you manage the course is the most generous, okay, worth value and quality among other providers in the market. My advice to our fellow BE candidate is to get familiar with the NCEES reference and the other standard references. I have hard time looking for the information during the test because of the way they show their references. For example, you have to know which chapter of the HCM to get the capacity, for example, and the volume to capacity ratio or a link group. Okay, don't rely on the keyword alone, but you have to know which chapter. Okay, as you know, the time management was the most challenging. Okay, so I hope that the course is getting spread among the fellow engineers. So this is what our friend that he suggested. Okay, I did my best, and he sent me a lot of questions, and communicated with him, and I did all my best to help him, and I'm glad that finally it's over for him. So, and I wish the same thing for you guys. Okay, so um, so the key here, if you remember the W6, the one I asked you to remember what is a W6, and this is what our friend or your fellow engineer is referring to. You need to get familiar with the design standard. As you know, for the transportation, we have the handbook V1.2. Chapter 5 is talking about transportation. In addition to that, in addition to the handbook, which is the NCEES handbook, you need to get familiar with the 9 design standards. I know they are very expensive and they are really very thick. For example, the green book, the geometric design of highways and street. This is a green book, and the HCM, as you know, had 3 volumes, and the 4th volume, okay, you can use it for example problem, but volume 1, volume 2, volume 3, and if you remember, I covered whatever I covered from these volumes. I always bring them and show it to you, and which chapter, which the highway safety manual, for example, this highway safety manual, the 3 volumes, also had the 3 volumes, and MUTCD, okay, and the roadside design guide, roadside design guide, roadside design guide, the 4th edition, and name it. If you, all these references already were talked about it, okay, and I showed to all of you, and I extracted from these references what information I believe that you need. I put it in my book, the textbook. That is really thick one, and maybe the new edition is even getting thicker. So this is about 650 pages. I did my best, and I presented the material, and it has many questions. Okay, and I will keep doing my best, whatever anything I can help you with. But you need to know the material very well, and you know which, for example, he is referring to something, the highway capacity manual. We talked about the LOS, level of service, the LOS, either the LOS for the freeway segments, okay, or for the expressways or multi-lane highways, expressways or multi-lane highways, multi-lane highways, this is the expression, and freeway, or we're talking about the two-lane conventional highway, two-lane highway. So in this case, the moment that you look to the question and you find something related to the LOS calculation, the level of service, you should know immediately, oh, this is here for the freeways and expressways. Okay, this is okay, chapter 12. Okay, they merged the two sections together this time in one chapter. It's called chapter 12. Okay, so and if you go to the MUTCD, and you have to know that chapter 12, it is in volume 2. It is in volume 2. So, and I covered all this before, as you remember. If you go to the chapter that I covered, this was the first chapter of the afternoon, which is a traffic engineering capacity analysis and the transportation planning. This was chapter 9. Okay, and we talked about all these equations and we went over them. These are the two equations. This is it is equation 12-2. Okay, page so and so of the HCM. I give you the reference. Every equation I extracted from any reference, I give you the page number and the equation number or the table number in order to make sure that you get access to it and try to do your best. Okay, so do your best, and the TRD, for example, the total RAM density, the one we talked about it before, and I told you how to calculate it. Even I came up with a table like this in order to help you how to calculate the TRD for different interchange configuration. This is a very effective way, let me put it that way, in order to train all of you to make sure that the TRD calculations is easy. Sometimes they're a little bit difficult for the description or for the engineer. Sometimes the TRD total RAM density is a little bit confusing sometimes, but I came up with this chart in order to and so on. So I try to do your best, and I all the equations and all the charts. And so going back right now to our discussion here in chapter 14, which is the signal design. Signal design, as I mentioned before, we have two references. We have the MUTCD 2009 and the HCM chapter 19. And you will find all these things here. I extracted from these references again what I believe that you need for the exam based on the NCEES exam specifications and topics and the subtopics. And I started last time, I said let me skip the first portion, which is based on the HCM 2016. I said that I went directly to the signal warrants because they are very important and a little bit confusing sometimes. And I said that per MUTCD, okay, we have the signal warrants. They came up with these 9 warrants, and I covered last time warrant number 1 and warrant number 2, and even covered warrant number 7 because there was a problem in the NCEES, and I covered this problem last time step by step. Those of you who attended the last class, you will find that the problem given in the NCEES problem 70 of the transportation of the NCEES transportation practice exam problems. We went over this and explained it very well, and we solve it together, and I hope that you get a chance to look at it again and see if you have any questions. So and also I mentioned something about the warrants, a little bit confusing. So what I did, I started this before, but I was able to finish it this time, where the warrants, I put them in a form of a flow chart. A flow chart, at least you can follow up. Okay, I know you are not allowed to take any material with you anymore, but I believe if you understand the warrants and comprehend the way that the MUTCD 2019, and this is part 4, by the way, part 4, because the book MUTCD, they divided into parts. You need to part 4, and also are going to get some information related to part 6, which is the safety, traffic safety in construction zones. We cover this in chapter 8 of my AM book. And also covered for transportation also. So if you look to the 8-hour warrant, you will find that the MUTCD, they provide us with a big table, and this table is divided to, this is the table. So I gave you the page number here. It is table 4C-1, page 438. So I give you every, for every reference, I used the table number and the page number. At least you can go and look at it and get familiar with it, how it looks like. Okay, this is verbatim from there, but always I encourage everybody to look to the original document, because this is what you will see on the exam, because you are not allowed to take any material with you anymore. Okay, unfortunately this is the case, but what can we do? This is NCAAS. So what I did, I took this and it translated into a flow chart like this. So so the warrant number 1, which is the 8-hour vehicular volume, I highlighted, or I put the major bullets, okay, or measure, okay, so it is any 8 hours of an average day. So an average day is a day that does not have any specific event. Okay, same 8 hours for both approaches. Okay, total volume for the major street. So if this is a major street, I call this is a major street, just hypothetical here. So this is called an approach, and this is called an approach. The volume that we are dealing with them, it is the volume of both approaches. So you take the volume from this approach and you add it, okay, and this is the total approach, okay, the total volume, sorry, from both approaches that you are going to use in the analysis. We were lucky in this problem here, a problem 70 of the NCAAS, because he gave us the total volume, okay, or total vehicles, okay, on major streets. So this is both approaches. Already he did both approaches. But I have some problems where this has been divided into 2 directions, one direction and the other direction. So this approach here, the volume could be given separately, and from this approach here, and in this case you have to combine them together by adding, okay, the volume of both approaches for any specific hour. Okay, so this is the first one. The second thing that I showed here, it is what about the minor street, or the minor, okay, minor road or minor street. So the minor street, they call this is an approach, and they call this is an approach, which is this direction here. Okay, here for the volume calculations and for the entering the tables of the warrant number 1, we take the one approach, which is a higher volume, whatever the higher volume is. So larger volume intersecting traffic. Obviously there is a signal here, because before we install the signal, there is a stop sign, sorry, there is a stop sign before we install the signal. We are investigating to see if a signal warrant is needed or not. If we meet the warrant, that means that a signal is okay, considered after all we do after we do all the engineering studies and so on. So along the minor road, we take the higher volume, either this or this, okay, but for the major street we add them. So this is called condition A, which is a minimum vehicular volume. Okay, so same 8 hours of any approach of the minor street, here it is, If condition A is satisfied, then warrant number 1 has been satisfied. If condition B is satisfied, then warrant, okay, 1 is satisfied. You don't have to satisfy A and B. If you look to the second page, okay, of my flow chart here, I will be glad to send it to you, okay, with a promise that you will not forward to anybody or load it on the net. There is somebody is working with a watermark here. Even if you try to make a copy, our name will appear on it. So if you look to the second condition, which is a condition B, interruption of continuous traffic. Okay, what is the principal reason? Okay, the principal reason. By the way, let me go back again to warrant 1 condition A. The condition A, the principal reason, by the way, where a large volume of intersecting, okay, traffic. Large volume of intersecting traffic. And you are going to see this from the table here. If you look to the condition A, you will find for 100% here, it is 500. And here for the condition B is 750. This is for the major road. But for the minor road, this is a major and this is a minor. For the minor road, you will find that this is 150 and here is only just 75. Do you see that? So the volume here is, okay, large compared to this, and it is opposite in the condition B. Okay, so we have here interruption of continuous flow, because this volume is very high, 500, 750, you have 600, 900, so very difficult for the people on the minor road to interrupt this traffic here. So they came up with this in order to satisfy, because the people on the minor road, we are going to be waiting a lot of are going to waiting for a long time, because they are controlled by this stop sign. They have to wait until they find a gap. Okay, so they try to satisfy both directions and see. If you look to the condition B, okay, the principal reason where condition A is not satisfied, if the condition is not, okay, and the traffic volume on the major street is so heavy, as I told you, 500, 750, that the traffic on the minor intersection street will suffer or suffers excessive delay. So they came up with the minor, okay, with the condition B in order to save, okay, the people, or try to help the people on the minor street. The same way, we are looking for the major street. We are going to take the two approaches and add them if they are not added. But for the other direction, okay, which is the minor street, we take the higher volume, okay, the higher volume. And here they are saying that minor intersecting traffic suffers excessive delay or conflict, okay, in entering or crossing the major street. This is the motive or the reason for that. Okay, so this is called condition B. These are the two tables as given in the, this is still continue on the warrant number 1. This is table 4C1. As you can see, this is exactly, okay, the how they look like in the original document. Okay, and we talked about all these things last time. Here right now, I try to translate the fine print under this table. Very important, translated into English by taking, okay, so step number 1, 100% basic. Okay, so warrant number 1 is satisfied if one of the following exists: either 100% columns on the major and minor of condition A, or 100% columns, okay, major and minor of condition B, because these conditions here, A and B, they have 4 columns. One, they call it 100%, which is, they call it the basic. This is a basic minimum hourly volume, and they take 80%, 70%, and 56%. So there are 4 columns, okay? And I talked about this last time, and today, okay, the flow chart will help us to recall what I was talking about when we covered that. Okay, so warrant number is satisfied if one of the following exist. What? So either 100% here, or be careful about or, by the way. Okay, now the code or the MUTC allows us to use what is known as the 70% approach. Okay, 70%, which is a 70% column. 70% on the major and 70% on the minor. So if you look to this 70%, 70% can be used only if, and only if the V major exceeding 40 miles per hour, or, the word or is very important, not and, a population less than 12,000. And this is what we did to solve this problem. If you remember the problem 70, he said the 85th percentile speed on the major street is given to be 45 miles per hour. So this is a V major, okay? And he told you the population is 12,000 to confuse you, because here the 70% criteria will be used if and only if I have the V major is exceeding the 40 miles per hour. Be careful, exceeding, not equal. Codes are so sensitive. A greater than or equal is different from greater, is different from less than or equal, different from less than. We have to pay attention what the code said, okay? Because one little tiny mistake, it could be really the source for the mistake or for the not getting the right answer. So here greater than 40 miles per hour and the word or, as I said, so we can use the 70%. In fact, we used it, by the way, in this problem. We use 70% in this problem because immediately when the V major exceeded, okay, the 40 miles per hour or greater, so in this case I can use it, because if you look to the volume of the 70% column versus the volume of the 100%, it is less. You see here it is, okay, which is basically 70% of that, which is, if you take 70% of that, this will give you, okay, 350. So automatically is less, okay? So if you have this condition here, this is a step number 2, okay? 70% columns, major and minor, for the condition A, or the 70% columns on, okay, condition B. Either this or this. This is for the A, condition A, and this for the condition B. Either 100% here or 100% here. 70% here or 70% here. Immediately when we saw the problem and the V major was greater than 40 miles per hour, I went immediately to this because it has less volume. Okay. So, okay. So you don't have to go to step number 1 if the problem stated that the 70% can be, okay, used either this or this, but not both. If you flip the page, you will find the 80%. So we covered 100%, which is a basic one. As you look to the bottom of this table here, it says basic minimum hourly volume, 100%. And we jump to 70%. 70% can be used only if, as I said about the speed and the population. Now we will go to the, and we are using or here, this or this here or this here, okay? Or 70% here or 70% here. So the word or, okay, the word or is used for the 100% criteria, and it was used for the 70% criteria. Now, when we go to the 80% and 56, now you will find the word and showed up. Okay, so, and this is a step number 3, the 80%, okay, the 80%. So warrant number 1 is satisfied if both of the following exists. The word both, as you can see, I made it a boldface. When 80% columns, major and minor for condition A, and 80% columns, major and minor for of the condition B. So in this case, and you have to, if you are going to apply the 80%, you have to satisfy the 80% column for condition A, and after that they said that if you have V greater than V major greater than the 40 mile per hour, the one, or the population is less, you can use 56%. Okay. So, but the 50%, okay, here it is, this step number 4, last step. So in this case, warrant number 1, if both of them, so and the 56%, like the 70%, if you remember the 70%, we used it only if the V major exceeding the 40 mile per hour or the population is less than 10,000. So in this case, but here the word and for the 56. Okay, for the 70%, no. 70%, it was this 70%. It was or. Okay, and this is what we did. Okay, so this is this is the whole story. I said that this is an overview for the whole story, and this is try to make it easy for you. Try to to understand. So the 100% condition A or condition B. Okay, and I mean they go together. That means this is the word or. Okay, 70% will be used only F. Here it is, like 56. 56 will be used only 56% used F. Okay, but the 100% and 70% they go together in the terms of the or, either one, condition A or condition B. Okay, but the 80% and 56% they go together in terms of the and. This they go together in terms of the and. So this 80%, if I apply 80% column, so in this case the condition A and the condition B must satisfy. The same story for the 56%. This is like a matrix, and this is for the whole thing. This, if you understand this, in this case, you will be able to solve any problem related to the warrant number 1 over 4-1, which is the 8-hour one. And this is exactly what we did. Okay, and the selection of this or this or this or this based on the given information. If you remember the problem that we solved, okay, because of the 45 mile per hour, immediately directed my attention to use this. And we found it that condition A is satisfied, so that's it. I don't have to go to the condition B. I don't like to waste time. I hope this is bringing, okay, if you continue, you will find this is the theme that I did with the warrants. If you remember, warrant number 2 was among, the warrants to be investigated for this problem. And this is what I told you. When you read the problem, you have to be very smart as far as the time. You just read the statement our friend sent it to me. He said that managing time is a critical during the exam, and this is the biggest enemy for you during the exam, because time, you have only 6 minutes, and with the CBT, so computer-based test, you are no longer carrying all these books with you and all these references. Now you are having access to the PDF. So the PDF, okay, so in this case you have to get control of the time. So the 4 possible answers, they give you warrant number 10, 1, so 2, 1 and 7, 2 and 7, and 1 and 2 and 7. And as I said, that we started with warrant number 1. Warrant number 1 has been satisfied. Okay, so in this case, that means this is out and this is out, since warrant number 1 has been satisfied. So I eliminated 2 answers. And if you are running out of time, as I said, and I was joking with you, but I hope that you will have enough time to go over the entire problem, that if I have only a few minutes left and I tested the warrant number 1 and I found warrant number 1 is is satisfied, so I get rid of the two answers. So what is left is two answers. I will pick one and pray to God if I have no time to investigate. Okay, if you go to the second one, okay, you will find that I have here 1 and 7 and 1 and 2 and 7. I told you that I will go to warrant number 2. I will not go to 7. And warrant number 2, as you recall, we covered it. This is a 4-hour warrant. The 4-hour warrant, here it is, the 4-hour vehicular volume. They came up with these two graphs, okay? And we have the standard and we have the 70%. And the 70%, again, if the V measure is greater than 40 miles per hour or the population is less than 10,000, immediately I will use this. And you have 3 curves. You have to decide which one based on the number of lanes in each direction, major and minor street. We have 2 or more lanes, or 2 or more lanes, and 2 or more lanes, and 1. So 2, 2, okay, and 2, 1, and 1, 1. And this is a 70%. And the x-axis and the y-axis, this is a 70% factor, or the 70% criteria. And you have to be careful because all points, the 4 points, they must fall above. Here it is, fall above. And this is what I did here when I did I just fall above. I put just hypothetical, okay, fall above whatever curve is used. So we need to make sure that all of them, they are fall above. So the x-axis is a major street volume, both approaches as usual, and this is a minor street volume. Here it is, and this is a 70%. So I said that the 70%, okay, 70%, okay, applicable if or, as we talked about before. So what is the 4-hour warrant volume? Okay, what the principal reason why the MUTCD consider that? Volume of intersecting traffic. So any 4 hours, okay, of an average day, all 4 plotted points fall above the applicable curve. The 70% factor can be used for this figure here. Use F, this, or the population less than. So this is a warrant number 2. Okay, this is what I presented to you, which is nothing other than just to translate this into English. I took the original graphs and I tried, okay, to make it, okay, easy for you. And if you remember also that when we solve this problem, I don't know if I send you the recording or not. I will be glad to send the recording. Sometimes I say that I do this, but I got really so busy. But the semester is almost over. I have the finals, or the students, they have the finals next Monday, which is tomorrow. So this week is the exam week for CCO Fresno. I'm teaching 3 classes, so forgive me, I'm so busy with them. I was helping them almost try to do everything I can do to help students, okay? Especially the seismic class, I teach it for the students. Seismic class that I teach at CCO Fresno, which is, I'm using the same book that I'm using for the PE, my own seismic book, the 5th edition. So it's really tough for them, but I'm trying to make it easy. Mechanics of materials also is a very important course. Also, I teach it, okay? So I am almost there. So this week is a final exam week, and after that I will be, okay, relieved a little bit from the Fresno State CCO Fresno, but I will be busy again with the PE courses, but I will do my best try to. So if I did not send the recording, it takes about 2 or 3 minutes just to send it. Just I pick the link and send it, and this link will give you access to watch it 24/7 for 365 days, okay, for these free webinars. Okay, But for the courses, no. For the courses only is limited only to those who are enrolled in our classes. Okay. So the moment that I saw there are two answers are left, I focused on one. Okay, that is not there in answer B, 2. So the moment that we found that 2 also satisfied, blindly I picked the answer D. So since 1 has been satisfied, I eliminated 2 answers. Since 2 has been satisfied, I eliminated this answer, and the only answer left is D. I don't have to go and investigate 7 to save time, because you have to, and they make it this way, they arrange this in a different way, and this is very common, by the way, very common. Okay. Very common. So I needed to be aware of that. Okay. So I need, since I mentioned something here last time, for example, we'll try to solve a problem, and thank you, our friend Hego. He told me that there was a typo, and they sent the correction or the errata, and I do have the errata here. Let me show it to you. Since I mentioned something here, you may be interested to know that, which I encourage you to. And also this, let me bring this, the errata. I think I got it here, but it seems to me I left it on the other desk. Yeah, this is the problem. I will go back again to the warrants in just a minute, but I try to remember almost everything. This is the, as you know, the NCAAS, they came up with these 4 books, the 4 white books that they have the let me bring one of them. It is here. Okay, these white books. Okay, this is the geotechnical. I have the transportation somewhere here. Let me get the transportation. I believe I have it. Here it is. Yeah, transportation. So this is a new one, but as usual, we are a human. We do mistakes. Nobody above mistakes. So always okay. Let us always, if you are aware of any typo or mistake or an error or errata like this here, so we were trying to solve a problem last time, and it does not make sense because, and one of you voluntarily, and thank you, Guzman, that he told me that there is an errata for this. This is a problem number 64. Number 64. He gave you, this is a roadside design. This is a roadside design guide. He's asking about the slope and the creek recovery zone and so on. We talked about that. And the issue, and here are this is a one from the AIT, the alternative item types. As you know, they started to do that. So this is the errata, the issue and errata. This year, by the way, posted, okay, 4/1/2023. So the revisions are shown in red. So here they reduce the number here, and they are saying that some values, okay, will be used more than once. So these are in the original document, in the original book, they released it last year. They have 24, 22, 20, 18, 10. So I have 1, 2, 3, 4, 5, 6 here, because there is a repetition, and this what caused a little bit when I was solving the problem. After I covered this subject, I said, it does not make sense. And our friend Hego said that, oh yeah, the issue and errata because there is a typo. So we have 1, 2, 3, 4, 5 only. So there are 5 here. Okay, and also they indicated here that some values can be used more than once. Okay, and they give you the slope, whatever is. So I needed to be aware of that. So this is always a check. I will do my best to check, and if you are aware of any okay, So I needed to be aware. Also, there is some for the also errata was posted. Okay, April last year. This is a compound curve, the compound curve that we solve together here. Okay, so whatever clarification, whatever. Also, there was one problem related to the California bearing ratio, the CBR California ratio. So they are okay. This I think it was a plus, but it should be multiplication, and they corrected this. So the solution for this one, I believe it was a plus. This is problem 74, but it's supposed to be multiplied by 74, which is 255, 11,300. Yeah, here it is. So this is not a plus. This is multiplied. Okay, so they corrected that. The answer is correct. It's still 11,300, but the equation itself, instead of a plus, they corrected. So please try whatever. Okay, and normally I check from time to time, but if I miss anything, please let me know. I really appreciate your help and your support with. Also, the so the erratas, okay, and also for codes, by the way, unfortunately, the codes, like for example, the MUTCD, the ASHTO, Green Book, and name it, all these things. The issue also errata from time to time to take care of any typo or mistake or an error, okay, and this is something that I hope that they corrected in the PDF that will be given to you, PDF, okay, but if they discover there is a typo or mistake or an error, and that there is a question related to this section that has a typo or a mistake or an error, they will take it out. They are going to eliminate this question if they didn't take care of the. So please try to do your best, and I will do my best. Let me know if there is any typo or any error or any thing even in my books. I really appreciate that. At least I can include this in my books. I'm extremely busy, especially I have 18 books. I have to. I'm working on mine now for the new NCEES. So it takes time, okay, and a lot of effort and a lot of engineers helping me. But even above all, we are mistakes. We are a human. We do mistakes. Nobody above all, we are a human. So please, if you catch any type of mistake or an error, please let me know. Also, some of you maybe did not attend yesterday. I'm helping, okay, few engineers are taking the exam very soon, and they took the class with me, or they purchased my material, and they ask for additional clarification of some items. Or so I do have workshops, live workshops every Friday. The day before yesterday, 5/12, I have one. 5/9, I have 10 of them, 10 live workshops, and the ID is still the same. So it's available on our homepage. If you go to our homepage, passpe.com, passpe. Everybody wants to pass his PE, so passpe.com. You'll find the instructions how to join if you are interested. It is every Friday from 3 to 5 Pacific Standard Time, California time. This is where I am residing right now, in California. So please, okay, do your best to attend if you are interested. And if you have any question, you can send it to me in advance, as either from my book or from my books or from other books. But let me know, and I appreciate if you can send me the question in advance. It will be good time to save time, okay, to save time. So warrant number 1 and warrant number 2, we talked about them. Okay, warrant number 3, which is they call it, okay, the peak hour warrant, and the peak hour warrant. And also in the flow chart that I prepared, the intent, okay, because the MUTCD, when they prepare a document or put a design, or they so they are always explaining the logic behind it or why they did that, and this is really good, right? This is helping us to understand the concept behind that. So I'm trying to find here it is. I found it. Here it is. Yes, it's written. So the warrant 3, I can read it from here because I provide all the curves. So this is basically the whole story. So, but you are very welcome to read it from my book. Okay, so the warrant number 3, which is, they call it the peak hour. What is the reason? The principal reason for that, the minor street traffic suffers delay entering the major street. So right now, again, I draw an illustration here. We have a stop sign here, and we have a stop sign here. Okay, and we might have an office building here, could be, or industrial complex here. So around 5 o'clock or whatever the time, okay, they releasing the people. So you'll find there is a lot of vehicles or cars are waiting, okay, to cross or to merge with the traffic on the major street. The major street is still the sum of the two approaches, the volume of the two approaches, as you can see. But here we look this approach or this approach, whatever the higher approach is, and this is the intent. If so, there is a stop sign here, there is a stop sign here, okay, and the traffic on the major doesn't stop. So this means that when the people leave the office or they leave this industrial complex, they are going to wait here for a long hour, and you'll find a stack of cars waiting. So they said we need to consider that. We need to consider that in order to install a signal instead of having this controlled by stop sign, as you can see. So this is the logic behind it, okay, or the principal reason as discussed in there. So will be applied, okay, in unusual cases. And this is the word unusual is given in the unusual, like office complex, manufacturer plant, industrial, okay, complex, okay. So any 1 hour, okay, so the 1 hour is defined as any consecutive 15 minutes. It must be consecutive. I cannot jump a quarter and go to the, so it must be, okay, on an average day, okay, and any 1 hour falls above the applicable curve, okay, if this is the only warrant, and be careful about that because I have a question about that, okay. So the traffic control signal should be the actuated one. Actuated one, they put loops here, they put loops. If this is the only warrant, okay, and this is, by the way, in the other two books. I have the other two books. Let me see if I have them handy here. If I remember, this is the practice problems and solutions. It has had about 203 problems, and if I remember, this is a chapter. Let me see here. Chapter what? Chapter 14. Chapter 14. For example, if I remember, I added one question here. Okay. Okay. Yeah, you see the traffic volumes here. Yeah. So traffic warrant number probably in the other book. On the other book, the practice exams. Specifically, I ask this question: if warrant number if warrant number 3 is the only warrant, okay, because we need only one warrant, okay, to be satisfied. You don't have to satisfy all the 9 warrants. And as we discussed last time, any warrant, any one of the 9 If has been met, okay, that means that a signal should be considered after you do the engineering study, as we talked about this last time. So if this is the only warrant, so the traffic signal here, as we're going to see, it should be a traffic actuated one. So the loops here and the loops here, okay, it will turn the signal to be green along the minor street if there is a traffic here. If there is no traffic here because the people already left, and after 5 o'clock, okay, there is no really a long line of, so in this case the traffic signal will be, okay, traffic actuated, mean that it will be working only if, okay, there is some traffic here, either through cameras or through loops, whatever the system they are using, because some of them are actuated, okay, with cameras, some of them are actuated with loops, okay, to indicate that make this green for this in this direction, so that people can turn right, or sorry, go through or turn left or something like that. Okay, I needed to be aware of that, and this could be a target for a question. Okay, again, they provide us with the figures, and here are the actual figures as given in the MUTCD. I give you the figure number, figure 4C3 and 4C4. Okay, so here also the probit. So we need only 1 hour, and this should be falls above the appropriate curve. And again, the x-axis is the major street volume of both approaches, and this is a minor street, the higher approach. Okay, they have the basic condition, okay, and they have also the 70% condition. Okay, this and or, and you need only 1 hour, okay, to fall or falls above the appropriate curve, whatever the curve selected here based on the number of lanes on the major and the minor street. So this is warrant number 3, which is, they call it the 1 hour. Okay. After that, they came up with the warrant number 4. Warrant number 4, they call it pedestrian volume. Warrant number 4. So I draw this. Obviously, when you go to the code, you will not find these drawings. It's just they explain. For example, this is warrant number 3. Here it is. I gave you the sections that is talking about the standards and the statement that I was reading for you. Okay, if this is the only warrant, okay, here it is. If this warrant is the only warrant, meet, okay, and a traffic control signal is justified by an engineering study. The word engineering study is mentioned, okay, many times in this chapter. The traffic control should be a traffic actuated. Okay, this is a statement that I told you that it could be a target for a question. Here it is. If this is the only, the word only is very important. Okay, that means that the light will be green, or the signal will be green. Okay, only and only if there is a traffic on the minor street. Okay, based on the adjustment, okay, either by the loops or by the cameras, to turn the green light on the. Also, we need to be familiar, by the way, since I mentioned the green. Oh yeah, let me just finish this. I'll show you the green. So this is a peak hour, which is a warrant number 3. And here are the 2. Okay, this is all what you will find. But what I did, as I told you, I tried to translate whatever the warrant, what the reason for it, what is the logic behind it, what are the parameters that involve in it. After that, we will go to the warrant number 4, for example. Okay, here it is, which is a warrant number 4. Okay, and also the warrant number 4, which is the pedestrian volume. I will explain it to you. But since we talk about the green and the red and the yellow, in MUTCD, I needed to be familiar with that. the arrangement, typical arrangements, okay, for of signal sections in a signal phases, okay, that do not, okay, control turning movements. It could be in a vertical signal phases, okay, or it could be a horizontal, or it could be a signal section of continuous movement, which is, they have a green arrow here. I don't know if you see the green arrow. Let me get closer. This is from the MUTCD. This is on page, by the way, page 458. I need you to be familiar with that as far as the arrangement. So it is red, yellow, green, and red, yellow, green, and in the green there is an arrow. Okay, you can see that. So I need you to be familiar with that. And immediately after this, for the vertical position, and this for the horizontal position, and this is the one that does have the green arrow for this, for the continuous movement. So they allow, okay, so the people are in this lane here, and they have this green arrow here. That means that they can, okay, go, okay, continuously. But the relative immediately under this figure here, or figure 4D dash 20, I can scan it and send it in my notes if you don't have access to the MUTCD, but I believe it's very easy to find and access. All of you have access, I'm sure, that to the MUTCD 2009. Okay, you immediately after this, either for the vertical or the horizontal signal phases, I need you to be familiar with this, even up to here, by the way. I need you to read this. I need to read this, okay? Okay, and they are saying here that the relative positions of signal sections in a vertically arranged signal phases from top to bottom shall be as follows. From top, okay, from top, here it is, to bottom. As we go from here to here, this is the top, and this is the bottom. Okay, they are saying that the circular red, yes, it will be there. In fact, they make it the one it's always there. It is the boldface uppercase. Okay, circular yellow. Okay, circular yellow, and the circular green, which is this basic one here. Okay, circular, and we're going to see the lenses here. They have two different sizes based on the triangle of vision, as we're going to see it, how far it should be from the driver's eye, and we're going to see. So this is the basic one. However, you will find that we could have immediately under the circle red, you can see a steady or a flashing, okay, left 10 red arrow. This, some of them, they have that, okay, or a steady or a flashing right, okay, red arrow. So left, so they might give you 4 instead of 3, okay. So I need you to be aware of that. And sometimes when they draw the flashing, by the way, on the exam, they draw something like that and they say like this, that this is the flashing. So there is, all these possibilities can be, okay, exist, and they might give you a configuration and not exactly matching this. You say, wait a second, what's going on here? Okay, so in this case you have to pay attention, okay, to these configurations. And here it is, the relative positions of signal. Okay, I needed to be aware of that, and I will elaborate this more about this also more when we come to the MUTCD. I include, I think, all this to the best of my knowledge. And barricades, also barricades are very, very important. Okay, the barricades, okay, I included in the MUTCD for the barricades. Okay, type 1. There are the 3 types: type 1 and type 2 and type 3. Okay, we need to be aware of these 3 types. I believe we talked about that before. Yeah, here it is. I think I include this page into my book somewhere. This is a barricade, okay, type 1, and this is the type 2, and this is type 3. Okay, the angle 45 degrees and the dimensions. They might ask you about the direction of the traffic, right or left, where this yellow, okay, it should be okay in the direction that the driver will turn. So we'll talk about that. But I remember the signal phases and the signal lights, green and sorry, red and yellow and the green. The yellow, the red and yellow and green from top to bottom, and we need to be aware of the possible, okay, other. And remember that the flashing one, it could be indicated, and they should indicate this if there is a flashing. They say that either a flashing, okay, and they give you whatever. Okay. So since we're talking about signals, so I just remember this. So I picked this section from the MUTCD. So warrant number 4. Warrant number 4. Right now we're looking for pedestrian. This is what they explain. Okay, and this is what I translate this. This is a translate into English. We have the major street and we have the minor street. They are saying that if we have a shopping center here, or we have a complex here, okay, and this here is stop sign, and here we have here stop sign along the minor street. So the minor street is controlled by these 2 stop signs. Okay, so the traffic here and the traffic here will wait until find a gap. What about the people? The people are going to wait here. So the traffic in both directions, as you can see. So they are saying that we need to take care of these people here. But they look to another item. They say that if there is another street that it has a signal here, it have a signal, no stop sign here. The stop is stop. There is a signal here where the people on the minor street can have a green and they can go this way. And the pedestrian who are waiting here, they can cross. It have a side, it has. So this is a traffic control signal. Okay, so they are saying that if this less than 300 feet, they are saying that if an installed signal shall be equipped with pedestrian signal head and will not be considered unless no restriction of the progressive movement. We're going to talk about the progressive movement, which is a coordination of the traffic signals. So if you look to the code here, it said that the traffic volume, what is the reason for considering this warrant or to implement this warrant? That the traffic volume on a major street is so heavy, said that such the pedestrian experience excessive delay in crossing the major street. So they are saying that the people will be waiting here in order to cross. So any 4 hours of an average day, okay, and a plotted points representing vehicle per hour on the major street at both approaches, and the corresponding pedestrian per hour, PPH, crossing the major street, all of them must fall above the curves of the MUTCD, the curve of the 4C5. We're going to see it on the following page. Or for 1 hour, and the 1 hour is considered consecutive 15 minutes, of an average day is plotted for above figure 4C7. We're going to see shortly what's the difference between 4C5 and 4C7. If you look to this, okay, okay, so the 4C5, okay, this is what is known as the 4-hour volume for the pedestrian. 4 hours. So we need 4 hours to fall above. This is the basic condition, and this is the 70% condition. Here they made a change. This is not 40 miles per hour. This is 35 miles per hour. Okay, if you remember, the 70% criteria was applied before when we have the V major, okay, exceeding 40 miles per hour. Here they drop it to 35 miles per hour, and the population, or the population. So we can consider the 4 hour, because they said that maybe, okay, 1 hour is not sufficient. So they look to 4 hours, maybe in the morning and the afternoon, any 4 hours, not necessarily to be 4 consecutive hours. Any, the word any, by the way, when they are talking about any 4 hours of an average day, and we talked about an average day before, it is a day that is not really a holiday, or the 4th of July, or the day on the Super Bowl, or before this, something, okay, an average day, okay, it does not have a major event or a holiday or something like that, such that there is no any a change of the behavior of the traffic. Okay, so they came up with 4 hour and 1 hour, because it may be, okay, there are certain hours the people will go for shopping and coming back, or they are living in a complex and they are leaving. All these things are considered, like a complex here, a shopping center here. So maybe after they leave the work, or early in the morning, they will go for shopping, and they need to cross the street to go back again to the complex. So they consider that. They consider the pedestrian. They need to pay attention to see, or don't like the people here waiting, okay, forever until they find a gap and there is a risk for accidents or something like that. So, and also they said that maybe 1 hour, and this is, they said, or, the word or is here is mentioned, or for 1 hour. Here 4 hours, here 1 hour, okay, and 1 hour, it must be 4 consecutive 15 minutes, it must be, okay. And this is a 47C. So here 47C is only 1 point, because it's 1 hour. And again, they give us the basic condition of this figure here, which is, you call it 100% if you want, and this is a 70% factor, and they adjusted the V measure, instead of 40 miles per hour, they made it, okay, to be 35 miles per hour. And this is also, it must falls above, like the previous cases, okay. And as you can see, the x-axis is the total major volume on both approaches, the x-axis in this one here and in this one here, and the y-axis here, this y-axis and this y-axis here, is the total pedestrian crossing street, pph, pedestrian, okay, total pedestrian per hour, pph. Okay, so I identify the axis and I just indicated this. So this is the warrant, okay, number 4. Warrant number 5, and again, if you go to my book, you will find that this is the description, warrant number 4. This is what I took and they translate into English. which is the diagrams that you are very welcome to read it either from my book if you have it, or from the original document. If you see there is any discrepancy or any typo or mistake or an error, please let me know. I'll be glad to help, okay, and correct any. Okay, this is the figure 4C5. This is the 4 hour, okay. And this is the 70% factor. Okay. And again, the y-axis is the pph, okay, and the x-axis is the vehicle per hour vph. This is vph. This along the major street, both approaches. Okay, if you flip the page, you will find the 1 hour. Okay, so they said the peak hour, pedestrian peak hour, because there might be one specific hour when the people are leaving their work and they go to the grocery store or the shopping center to go and, okay, so again, the x-axis is same, the y-axis is still the same, but here we need only 1 point. It is the peak hour. Okay, if we are eligible for the 70%, this is the 70%. Okay, this is a 70% factor. Also, we need, okay, 1 hour falls above. So this is a warrant number 4. If you look to warrant number 5, which is school crossing. Okay, this is the language that is given in the MUTCD 2009. School crossing warrant is intended for application, okay, where the fact that the school children across the major street is the principal reason to consider installing a traffic signal, control signal. For the purpose of this warrant, the word school children includes elementary through high school. So again, they define what is meant by school children. Okay, elementary through the high school. Okay, maybe your kids will not accept that, especially if they are in high school and said you are children. I said, what? We are kids. No, we are not kids anymore, but that's fine. Okay, so, and they start to explain the standards, because the MUTC, they have something called the standards. Okay, and if you look to the translation of this, I put it this way. Let us look to warrant number 5 to see if the warrant number 5. Okay, so we finished warrant number 4. Warrant number 5. School crossing. School crossing, which is warrant number 5. Okay, what is the reason? The principal reason for installing a signal that school children, and here I define it also for you, or I include the definition, or I include the definition, I did not define it, they define it for us. Those are elementary through high school across the major street. There is a school here, and there is a stop sign here. Okay, and the students, when they leave school, okay, I know there will be somebody who's trying to help the students, but if the volume here is so high, okay, so they said that if this school, these kids are leaving, okay, whatever the time, and they try to cross for whatever reason to go to the other side, okay, maybe they're living in this complex here, or they are living here somewhere, so they need to cross this street, the major street. This is a major street. So this is what the code or the MUTCD said, that what are the standards for installing a signal because of the school crossing, minimum of 20 school children during the highest crossing hour, frequency and adequacy of gaps of the vehicle of the traffic stream, other reasons or other measures of warning signs and flashes, school speed zone, school crossing guards, or a grade separation crossing. If there is a grade separation, this will be great. Okay. School crossing signal shall not be applied where the distance to the nearest crossing signal is less than 300 feet. This is something very, very important. They are saying that if this is whatever the street is, and here is the school, and if you have a signal here, this is the first street, for example, and this is the second street. Okay, the school is at the corner of the second street and major street, whatever it is, call it Shah Avenue. Here we have a stop sign, but there is a near street, first street, it does have a signal here. And this distance is the 300 feet. So the code said that let the kids, they walk this here and come here and cross. And they can go back again, okay, to, or they can go this way, whatever it is. So this is in order to get the maximum benefit, because if they are 300 feet, so you know the pedestrian, we are walking on the average, as you know, 3.5 feet per second. We're going to see today. Sometimes they put it 4.0 feet per second. Sometimes. Okay, the HCM, MUTCD, this is what they are recommending, MUTCD, 3.5 feet per second. I believe this was mentioned in one of the problems. Yeah, here it is. I believe here it is. It is no, they are telling you use MUTCD only. So here it is. So this is the crossing. So it is 72 feet, which is the crosswalk divided by 3.5 feet per second. It is given, by the way, on MUTCD, MUTCD page. I can remember 2009. I can find it for you very quick, okay, or during the break I can show you where is the MUTCD gives you the 3.5 feet per second, and this is the one we use it by the default. I believe probably it is here. Okay, so yeah, here it is. It is on page, by the way, page 497. So it is 3.5 feet per second. Here it is, 3.5 feet per second. This is what the MUTCD. This is on page 497. So if you have so page 497 of the MUTCD. So the reason I mentioned that, so because my kids, okay, will object, Daddy, oh, I cannot walk 300 feet. I said, how many minutes does it take from you guys if you are walking, okay, 3.5 feet per second? So how long it will take from you? Even if it is 350 feet or 300 feet divided by 3.5. And this will give you how many seconds divided by, okay, 60. This will give you about, okay, 1 minute, okay, 1.4 minutes. So this will take about, on the average, okay, 1.5 minute. So a couple minutes. Walk, guys, okay, walk a couple minutes, okay, at the end of the school day, and you go, or at the beginning in the morning, you can come here and cross here safely and go to the school. 2 minutes each way. But anyhow, this is just to let you know that. So this is what the school crossing, okay, and they put here the number of school children, okay, during the highest crossing hour when they leave. If there are 20 students are waiting here, it tried to cross. So minimum 20 of school children during the highest crossing. Okay. So okay, so and there is no gap in the traffic along the major street, so we look to this in order to, okay, this is a warrant. Okay, number 5. Okay, right now is almost 10:30. Let's take a few minutes break and come back, and we'll continue with the remaining warrants, and after that we'll go back again to the beginning of the chapter to wrap it up, and let us do our best here. Okay, so let's take a few minutes break. Right now is about 10:29 California time. Come back after 10 minutes, get some fresh air or fresh water, and come back with open mind and open heart where we can continue our discussion. Okay. Yeah, welcome back, everybody. Let's continue our discussion here. So the next warrant is warrant number 6, the coordinated signal system. When signals are closely spaced, it is required to coordinate the signals. And here is found there is a typo, warrant number 6, coordinated signal, not school, signal, okay, system. So here, if there is a signal here at this intersection, and there is another signal here, and the distance is okay less than 1,000 feet. Okay, so this warrant it tried to coordinate, because if they are closely spaced, okay, and if you look to the principal reason, in order to maintain the proper platooning, by the way, when you hit a green here, okay, you move, and if this is green, this is a perfect synchronization, okay, and there is a time space diagram. We're going to see it shortly, talking about that, and there is an equation, and there is a problem given in the NCEES. So the MUTC standards concerning the coordinated signal system, that a traffic signal, okay, shall be considering one of the following, okay, criteria: one-way street or two-way street. Okay, so in order to maintain the platooning, okay, between the platooning along of the vehicles along the street, along the major street, obviously, and they put a guidance here that this warrant should not be applied, and so on. Okay, and here it is. For example, the guidance, okay, it say that the coordinated signal system signal warrant should not be applied where the resulting result spacing of the traffic on signal, okay, would be less than 1,000 feet. So I indicated this also in the drawing. So here, if you look to what the MUTCD said, that a progressive movement in a coordinated signal system sometimes, okay, necessitate installing a traffic control signal at intersections where they would not be otherwise be needed, okay, in order to maintain a proper platooning of the platooning is very, very important. Platooning. Do you remember platooning was mentioned before, by the way, the word platooning? Okay, if you remember chapter 1, let me take you to chapter 1, and chapter 1 of my book, or chapter 9, in fact, let's call it chapter 9, okay, which is the chapter is related to the chapter 9, because 8 chapters for the AM, and after that we start chapter 9. This is the new numbering system, which under traffic engineering. Okay, there is one section, okay, at the end of this chapter, and we let me bring it to you, which is for the pedestrian. And the pedestrian, okay, as all of you know, is very important. Okay, and I will show it to you. Here it is. It is given on my book on page, and this is what I'm trying to do, by the way, in the new, okay, editions. For example, this here in my book on page 195. If you have my book, page 195, this is the pedestrian facilities, okay, pedestrian bicycles, and so on. And this section is taken from the HCM, okay, 2016, volume 3, interrupted flow. This is because the 3 volumes, the volume number 1 of the HCM is a basic condition, or the basic concept, or the concept as they call it, and volume 2 uninterrupted flow, and volume 3 is called interrupted flow. And this, so basically, if you put down, okay, or write down in every section you read, or every equation you see, or every table you see, ask yourself the W5, W6, the one I was telling you, something like that. So this is, and the platooning, by the way, was indicated here, okay, exclusive and shared and stairways, and this is applicative. So there is a table given. Okay, the previous table, that the one we used to determine the LOS for pedestrian, which is taken from the HCM exhibit 24-1 on page 24 of the HCM 2016. So this is the average flow LOS criteria for, okay, criteria for walkway. Okay, and we have the 6 level of surface A, B, C, D, E, and F. Okay, and they came up with another table, which is, I put it here, platoon. Here it is. So platoon, okay, when a group of pedestrian, they are walking together, okay, and they are really, okay, causing, okay, delay because of the platooning. I believe I showed you a picture of platooning, okay, where a group of pedestrian, they are walking together as a group of engineers. They are walking, they are crossing the crosswalk, or they are walking along the crosswalk during the lunch break. They are going for a lunch, and they are talking about the BE exam. What will be on the BE exam? Did you cover this? Do you know what is this? What is this? So they are working, or they are walking together, and they are blocking, okay, the crosswalk. So this is the level of service will go down, and will solve a problem. So the platoon, okay, so this is what is meant here for the warrant number 6, okay, which is the coordinated signal, which is the one I put it here. Okay, if you look to warrant number 7, this is, it was related to the problem that we solve it together, which is a crash experience. Crash experience, okay, they look to see the number of crashes. So the principal reason for installing a signal, because warrant number 7 has been satisfied, is the severity and the frequency of crashes at intersections. If there is one specific intersection and they have a number of crashes exceeding these limits, or equal or exceeding these limits, obviously this is the reason for installing a signal. So they said that a traffic control signal shall be considered if all of the following are met. Okay, other alternatives fail to reduce the crash frequency. We need to study, or this always they use the word engineering study. So we need to know what are the reason for the these frequent crashes, the pavement condition, the side distance condition, or maybe the light. If the accident happening at night, not enough lighting in this intersection, maybe the signs over there, they are faded and they are not easy to read at night, stop sign or any yield sign or any sign over there. Okay, so we need to look to see what all alternatives, okay, that we can implement in order to reduce the number of crashes. Maybe the people are careless and they don't pay attention and they need a police enforcement over there. So we can call the police department to enforce, okay, the people, okay, behavior, or to control the people behavior, or enforce, okay, the traffic, okay, over there, to everybody to follow the traffic, either speeding or don't pay attention to the stop sign or whatever it is. So we looked at it. So if we try, but we couldn't find any reason, or the number of crashes have not been reduced. So in this case, if you have 5 or more, okay, crashes have occurred in 12 months. Okay, so this is what the a number of crashes, okay, they use as a criteria. And this is what we did when we solved this problem number 70. He told you that the 9 months crash history, he gave you the 9 months crash history. They said 3 right angle crashes, 2 rear end crashes, and 2 left turn crashes. And we need, by the way, the crashes, we have to be careful, because if you look to the MUTCD about the crashes, we need to make sure that the crashes that, okay, that will be prevented by installing a signal. So the crash experience signal warrant conditions are intended for application where the severity and the frequency of crashes are the principal reason to consider in traffic the signal. So we need to be that. He said that the need for a traffic control signal shall be considered if an engineering study, always the term engineering study, I need you to remember that, okay, because we have to do a very good engineering study, or an engineering study. Forget the word good, okay, an engineering study, okay, that all, the word all I put it, okay, and they put the number of crashes, and so obviously in our problem that we exceeded the limit. And the item number C, which is 3 items here in the original document, they have A, B, C. So for the crash experience, okay, so it is 80% of the column condition A or 80% condition B, okay, have been met, which is the warrant number 1, which is the 8-hour warrant. Okay, and if you look to the problem, I believe, if I'm not mistaken, they said here immediately after accidents, they gave you 9-month crash history. They said alternatives to reduce crash frequency have not resulted in any reduction of the accident rate. You see, an order is telling us we tried to reduce this number of crashes by alternative methods, by other alternatives, but the number of crashes did not really go down. That means that we did every effort or every alternative in order to get rid of these crashes or reduce the crashes or eliminate the crashes, okay, but it didn't work. That means that because we have to satisfy the code, and the MUTC did say that other alternatives failed to reduce the crash frequency. So in order to tell us that this has been failed, they mentioned this statement in the problem statement. So pay attention to every single statement that listed in the question, because it means something. It means something, okay? We need to make sure that we are aware of all these things, okay? So let us go to the one before the last one, which is a roadway work, which is this one here, roadway work, which is warrant number 8. Okay, the principal reason for considering a signal because of the roadway work, which warrant, okay, is to encourage, okay, concentration and organization of the traffic flow in a road network. Again, if one or both of the following criteria have been met, I listed them. This is like I couldn't find something just to represent as far as the drawing. So always, okay, I try to find something to translate into English. So maybe I will look for something that innovative in order to consider this. But this is, I need you to read it, and it is given in my book also. Okay, and the last warrant, which is warrant number 9. Okay, this is the intersections near a grade crossing. Near a grade, okay, crossing. They came up with 2 conditions where the distance D, okay, the distance D. Okay, so what is the reason for that? The reason for warrant number 9, that none of the previous 8 warrants are met, okay, the proximity of the intersection proximity to the intersection of a grade crossing on an intersection controlled by the stop or by the yield. So they are saying that if I have a railroad here, and this is a major street, and this is a minor street, okay, and we have traffic this way, traffic this way, and this is a stop sign, okay. This is only one lane in each direction along the minor street. If you look to the second drawing here, okay, probably I can bring the this is the other the same intersection here, and we have this here, and this is grade crossing, two or more approaches, okay, at the track. Here is only one. Here is only one, okay, one approach. Let me bring the color. Probably the color will help you and help me also. Okay, let me get the green one, the green section. Okay, here we go. We're getting close. Here we go. Here it is. So this is, let me get it close here and zoom. So this is the first graph. This is the warrant number 9 intersection near a grade crossing. We have a railroad, and there is a distance D. This distance D measured from 6 feet away from the nearest track to the stop line, and this is a major street, and this is a minor street. Okay, and here we have the major street total volume, and here the minor street, okay, the approach vehicle per hour. And here are different values of the distance D. This if the minor street has only one, okay, on approach. Here the minor street, the second graph, it does have two. It has have two lanes here, and we have a through lane here and right turn here. The distance D is also measured. So this is here two or more approach lanes on the track crossing. So they are concerned about the when we are crossing, okay, the track. In this case, they look to see if a signal warrant is needed or not. They came up with 3 tables, by the way, where we can adjust, okay, for the conditions that might exist. So and we have here the discussion I have. Let me just show it to you. And I have a problem, we'll solve a problem, but let me bring the discussion first. They are saying that a traffic control signal shall be considered if an engineering study finds that both of the following, okay, the center of the nearest track, which is 140 feet from the stop line, okay, or yield, okay, the plotted, okay, point falls above, again the word above, okay, and he gave us 3 figures, as you are going to see. The 2 figures, sorry, the 4C9 and 4C10. Major street volume should be adjusted if needed. So the minor street volume, minor, did they say major? No, minor street volume, okay, should be adjusted if we have 4C2 and 4C3 and 4C4, okay? So what are these 3 tables? The 3 tables that adjustment factor for daily frequency of the rail, okay? So it depends how many rails a day, rail traffic per day, so we can pick a value from here, okay? If 3 to 5, that means that adjustment factor is 1. And the second table is adjustment factor for the percentage of high occupancy buses, the HOB, high occupancy buses, okay? Again, the high occupancy buses, it depends on the percentage. This is the table, okay? So if if it's 2%, so that means that it is this number here. And the third table is that adjustment factor for the percentage of a tractor trailer, this long, okay? So if the distance D is less than 70 feet, or if the D of 70 feet or more, and here is the percentage of the trucks. These three tables are really, really important, and we need to adjust. I think I showed them. You will see them here. Here we go. Here it is. So these three tables, these adjustment factors. So the adjustment factor for daily frequency of the rail traffic, okay, the number of rail traffic per day, and the adjustment factor for the high occupancy. High occupancy, by the way, a high occupancy bus is defined as a bus occupied by at least 20 people. They define it for us. Okay, and the last of the adjustment factors, the percentage of the trailer trucks, how many trucks, okay, and it depends on the distance D, and the distance D, as I mentioned in the two graphs, if you look to my book here, so there are two graphs. This is, it's one lane in each direction here, and this is the distance D, and the distance D is measured 6 feet away from the nearest. Okay, if you look to the second graph, and this is, we have here two, okay, we have two or more approach lanes at the crossing, and the distance D is still the same as the 6 feet away from the nearest track. So the x-axis is a major street total volume on both approaches, vehicle per hour. This is a major street. So we look to the volume on both directions. So both approaches, we take the both approaches. Okay. So, and the y-axis in this case is the minor street crossing approach. Okay. Vehicle per hour. Okay. This is the highest approach, obviously, and we need to adjust. So we need to adjust the volume along the minor street, because the minor street is the one, okay, crossing the grade or the railroad grade. So in this case, we need to apply adjustment factors if needed, apply if needed. And I believe also in my book, I believe the red, I think I have one problem. Yeah, here it is, if I remember correctly. A problem here, problem number 127. It says here, consider the following intersection. Here it is. I have one in each direction. Okay, and there are two lanes in each direction of the major street. So I have two here and two here. Okay, and one lane in each direction of the minor. So we have, this is the total volume here. The hourly volume in the minor street is 70 vehicle per day at a distance 140, no, 100, only 100 feet from the rail. Okay, of the single rail, the distance. The traffic is located. It is known that the minor street has the minor street we have 4%, high occupancy buses. Here it is, high occupancy buses, and 20% tractor trailer. Okay, the minimum vehicle per hour on the major street, okay, per MUTCD must be what? So right now, the minimum volume vehicle per hour in the major street. So because right now we have 70 vehicle per hour along the minor street, and we have two things need to be considered. We have the distance, by the way, the distance is 100 feet from measured here to here. Okay, so in this case, if you leave 6 feet here, this is going to leave us with the distance D of 94 feet. 90, you have to subtract the 6 feet as given in the code. We have to leave 6 feet okay, from the, so if you look to my solution, let's look very quick to see, okay, and this is 127. Hopefully that, okay, 127. Yeah, here it is, 127. So what I did, the tables, do you remember the tables? Okay, so right now this is the adjustment for the frequency, and this is the adjustment for the high occupancy, and this is for the percentage. So right now for, okay, so the adjustment factor for the high occupancy, it is 1.19, okay, which is this one here, because he said 4%. If you remember the 4%, so I have 4% is given, 4%. So I go to this table and I pick the adjustment factor. And the second adjustment factor I need, okay, for the truck, okay, tractor trailers, okay. So it is also the percentage he gave you, I believe 20%. It was 20%. If I'm not mistaken, yes, it is 20%, yes. So I come here 20%, so I pick the 1.35, okay. So the volume along the minor street, it was 70, okay, was given. Along the minor street was 70. So I multiply the 70 times 1.19, which is the first adjustment factor, due to the high occupancy buses, multiplied by the 1.35, which is adjustment for the tractor trailer, the percentage. So it came about, okay, this number here. The distance D, in order to use it, I have to subtract 6 feet from the 100 feet, because the 100 feet was given, okay, to the nearest track. So I have to subtract the 6 feet. So right now this is going to give me 94 feet. So in this case, we are going to do what? Okay, so we are going to look to the 113, which we just calculated. Here it is. I will go this way horizontally, and also in the PDF, all of you know that the PDF has a command, okay, the PDF, Adobe Acrobat, okay, Adobe Acrobat PDF. I believe this is what they are using. You can use vertical line and horizontal line, and I'm sure that all of you are experiencing this or practicing in order to ensure that that this is okay, this is what we are looking for. So you are very, very important to make sure that the horizontal line, vertical line, using the Adobe Acrobat. So we go horizontally at around 113. Obviously, this is 100 and this 150. This is the volume along the minor street after the adjustment, and you hit the proper D, and after that come down and read, okay, what is the volume along the major. So it is, he did it reverse. So we ended with about 200, I believe, 200. So and you selected the answer B as in boy. Okay. So he gave you the volume here. He gave you the distance from the stop line to the nearest rail. Don't forget to subtract the 6 feet, as I mentioned, and he's asking what is the volume along, okay, the major street in order to meet the MUTCD warrant number 9. This is warrant number 9, as all of you know, warrant 9. Okay, makes sense. So it could be, okay, it could be a question like this, and also not necessarily computations. Okay, for example, here it is. Question number 126. Let me, question number 126. What do you think? The answer A or B or C? I know we're getting closer to lunch and probably say, oh my God, lunch is the best thing that. Okay, I will put this in front of you. This is the whole story, the overall. So warrant number 1 is satisfied if 100% of condition A has been satisfied, or 100% of condition B, and if the facility is eligible for the 70%, as long as either one of these. So also warrant number 1 is satisfied if condition A or condition B. So this is or, as I said, and anyone, as I told you, we need only one, okay, to be met. You don't have to satisfy all of these 4 corners here. This is a corner number 1. This is the northeast corner. This is the northeast, and this is the northwest, assuming that the north arrow this way if we go to surveying. And this is the southeast corner, and this is the southwest corner. Okay, so let me define it by corners here. Okay, but when we go to the 80% and 56%, so 80% condition A and condition B must be met. If we go to the 56%, if the facility is left for 56%, so in this case, condition A and condition B. So they play a lot with this, and this is a good example for that the warrant number 1, which is the 8-hour vehicular warrant, is satisfied if, okay, only, okay, 100% condition A is satisfied. Yes. Okay, only 100% condition B is satisfied. Yes, this or this. But when we come to 80% of condition A and 80% of condition B are satisfied. So if any one of these, okay, has been met, in this case is satisfied. So what is the best answer right now for 126? Okay, 126, let's go to 126. Hopefully I answered correctly. Okay, I give you, here it is, the table again. I don't know, did I put the fine print? Probably. Okay, will be a good idea. Maybe instead of this, maybe I will place this. Okay, place this summary here as part of the solution, but I put the tables again in order to tell you that so the answer D was selected, the answer D. If you selected the answer D, which is all of the above, okay, if satisfied if only this or this or this, okay, but I don't need all of them. Okay, so any of these is satisfied if only this or this. I hope that you agree with that. Okay, solution, or you agree with the answer D. And the language sometimes a little bit tough or sometimes confusing, but I hope that all of you are in agreement with this. I do have a problem, by the way, at the end of this chapter or this section here, which is a problem also similar to what we just did, but here I'm asking, okay, maybe the color is a little bit dark. I gave you 120 feet here from the stop line to this here. Said that the figure shown an intersection with urban city. The major street has 2 lanes in each direction, while the minor street has only 1 lane in each direction. The hourly volume along the major street, here it is, the hourly major both approaches, as I told you, is given. This is a problem number 13. It is, okay, 250. The stop line, okay, on the major street is located 120 feet from the rail, from, okay, single track, not double track. Okay, and it is asking the minimum, okay, the minimum approach volume, okay, on the minor street. So basically I solve it, distance D and all these things. And now we are, this is given, okay, 250. So this is 300 and this is 200. So 250, we hit the proper D, and after that we read the number to the nearest. Okay, and normally they give you answers that. So this is reverse to what we did, and I hope this is a good example for okay. So those are the 9 warrants. I need you to be aware of these 9 warrants as okay. So let us very quick to go over the starting the section from the highway capacity manual, the HCM chapter 19. Okay, so there are still some sections from the MUTCD. I will go over it. Okay, which is basically the MUTCD. When I was talking about, or let me finish the MUTCD first. Okay, if you go back, if you go to back my page, page 448 of my textbook, the 5th edition, the 4th edition, sorry. Okay, the 448, you will find that if you remember about the pedestrian speed, the 3.5 feet per second, and the discussion is at 3.5 or 4. This section here, which is the HCM 2016 concept of establishing walking speed. So they said the average pedestrian walking speed SB is intended, okay, to evaluate, okay, okay, comer and crosswalk, okay, crosswalk performance, the average so and so, and they are saying that 4 feet per second, okay, is recommended for intersection evaluation. As you know, it depends on the age, by the way. They are saying that if from 0 to 20% of the pedestrian traveling, okay, along the subject segment are earlier 65 4 feet per second, and after that they use the 3.3 and 3.5. They mention it here also because all this based on the generally recommended walking speed is 3.5 feet per second, like the MUTCD, okay, represent slower than the average speed. However, okay, so basically the MUTCD, they are adopting the 3.5 feet per second, as we saw one of the problems, by the way, 3.5 feet per second. And also, by the way, I don't know, it could be a target for a question. If more than 20% of all pedestrians are elderly, an average walking speed is 3.3 feet per second recommended. Okay, in addition, an upgrade 10% or greater reduces walking speed by 0.3. So also the age and the grade, if the grade here is upgrade and greater than or equal 10%, they said obviously this will affect the walking speed, and it says that it can be reduced, okay, reduced walking speed by about 0.3 feet per second. So 0.3 feet per second also is a reduction due to the grade that exceeding, okay, the 10%. Okay, so please read this section, and this is in chapter 19, if I'm not mistaken, of the same chapter, chapter 19. It will be a good idea, maybe, okay, yeah, it is chapter 19, because on the previous page there are a couple problems. I will go over them this afternoon. So probably it will be a very good idea if I can add here page, okay, so and so from chapter so and so, will be a good idea. Okay, at least you know, okay, because when I talked about the problem that here it is, they are asking what is the MUTCD most the time, okay, the pedestrian clearance time, problem 68. This is per MUTCD page 497. and if we know the length of the crosswalk, which it came out to be 72 feet. So if you divide 72 divided by 3.5 feet per second, give you about 20.5 seconds. But if you use 4 feet per second, will give you 18, by the way. Okay, which is also the answer over there is 18. But here he said that per MUTCD, so the MUTCD numbers will be used in this case. And there are other two equations we are going to see this afternoon to calculate, by the way, the pedestrian, okay, pedestrian clearance time. They came up the HCM, instead of using just the equation, you divide the distance by the speed, by the pedestrian speed, which is SB, normally with SP. Okay, they are using the SB for pedestrian speed. They came up with two equations. We are going to see them this afternoon, and I will bring this problem one more time. This is from the MUTCD, from the HCM. The MUTCD, they have this here, which is the figure in front of us, MUTCD 2009. It is the lateral, okay, and longitudinal location of the signal phases. So if this is the intersection in front of us here, so this is the intersection here. Okay, and this is the stop line. Here it is, where everybody has to come to stop. So if a vehicle is waiting here, which is normally about 8 feet from the front bumper, here they put it 10 feet. Okay, so this is called cone of vision, cone of vision, where they found that we are capable of covering an angle of 40 degrees. So they said that if you put the signal housing, okay, we have the red, yellow, green, the one I was showing you this morning. Okay, how far it's supposed to be, okay, and we are going to see how high also. So we need, if the pedestrian, if the passenger in his car, which he is 10 feet behind the front bumper, and the front bumper, we assume it to be at the stop line. So in this case, they found that this cone of vision, okay, and they said that how far it should be. They give us distances, how far the signal housing should be in order to be visible to the driver or to the users in this case. It depends if it's 12-inch signal, so that right now the diameter is 12-inch, and I think all of them right now 12-inch. It used to be small, and this 12-inch, and okay, a 12-inch or 8-inch signal indicator, okay, used based on. So there are some asterisks here as far as 12-inch. Okay, so they are saying that you see the cross hatching here. So if the 12-inch, okay, but if we have 8-inch also, which is a smaller diameter of the signal, okay, so it is 12-inch signal installation or 8-inch signal, okay, installation if used based on, okay, the option of section so and so. And they said that if you look to this, you have one asterisk, which is this one here, and two asterisks, okay, and the three. So 1 and 2 and the 3. And this is given, by the way, figure 4D on page 463 probably it will be a good idea if I can grab this 463 of this uh, uh, figure 463. Let me see if I can get it very quick. Sometimes here it is. I think we are getting close. Here it is. It's a very nice, probably in the future. Okay, I will get this. Here it is. So this is a figure that's given in the MUTCD. So again, as you can see here, and this is the first distance with an asterisk. This is okay, minimum distance of a signal phase from stop line, which is, and the 120 feet, it is a maximum. You see that there is a maximum distance from the stop for 8-inch. So 120 feet for the 8-inch, but if you look to the 180 feet, this is the maximum distance from the stop line, obviously, for the 12-inch. So this is what I need you to be aware of. This is called the cone of vision, which normally sometimes I joke with you that I need your angle, I need your eyes to be open at least 45 degrees, especially after lunch, when the lunch, especially if the lunch is heavy or the lunch is containing too many calories. Okay, so we need to be aware of that. So this, it could be also they ask you the distance, the minimum distance, the maximum distance, all these things we need to be aware of it. Also in the MUTCD they came up, so I needed to be aware of that. This is the figure I'm referring to. Also they look to the here I have some discussion, by the way, mounting height of signal phases, how high it's supposed to be. So I came up with a drawing in the following page. Is telling us here if this is the housing, this is the signal ball here, okay, and this is a mast arm. Okay, and this is the housing, the signal housing, okay, red, yellow, green, okay, and this is the surface of the pavement, finished surface. Here it is. Okay, so this is the height measured from here to the top. Okay, so they measure to the top of the housing, by the way, not to the bottom. Okay, so they consider this is the distance, the vertical distance, if you like to call it. It's not a vertical clearance, but the mounting height, okay, measurements per MUTCD. They came up with the graph, and this graph is given on this page here. Was also okay. So this is the maximum mounting height of signal phases, okay, located between 40 feet and 53 feet from the stop line. So the horizontal distance, and this is the height. And I believe I just saw the figure immediately after this cone of vision from the MUTCD. So it's supposed to be on page 460 something. Yeah, 465. So here it is, 465. So this is the original. They have, it used to be in metric and in English, but they have it only in English right now. So it is 4D5, the maximum mounting height of signal phases, okay, located between 40 feet and 53 feet from the stop line. So the distance from the stop line is given, and this is the height top of the signal housing above the pavement. This is why I said it's measured to the top. So you come here horizontally and you go up and read how much the vertical distance I needed to be aware of. This is just in case if they ask you. I don't know what they are going to ask. I wish that I know the questions, but I'm doing all my best. But as you noticed this morning from the email that I received from the friend that the books and the course, he took both of them with me. So probably, okay, this is the main reason that he passed, according to him. But I cannot claim anything other than just I'm doing all my best. And always let me know if there is one topic or one subject is not really covered to the depth that is supposed to be. I would be glad. Always I look to my notes and my equations and my problems, okay, based on that. Okay, so this is something I needed to be. Also, I included something here, the top of the signal housing, okay, of a vehicle signal phase located over some version. So in order to ensure there is a vertical clearance so nobody will hit it. And I included this drawing here, the one I came up with, in order to translate. This is not given in the MUTCD. I try to come up with whatever illustration I can come up with in order to, okay, so this is something that I needed to be aware of. So if we start right now by looking to the signal design per MUTCD, so the LOS, they have also 6 level of service, signal intersection analysis, and LOS determination. Okay. Also, they have the level of service LOS from A to F, as all of us know. So the concept of the level of service, okay, per HCM is defined as a qualitative measure describing the operational conditions within the traffic stream, okay, and their perception by motorist and or passenger. So they have 6 level of service A to F, level of service A being the best, and level of service F is the worst, as all of us know. Okay, and we talked about this and we killed it to death in previous. So also the driver, okay, comfort and okay. Sometimes I underline some stuff, by the way. I believe the underlined text or the bold-faced text is important, so you can consider that. After that, you will find series of definitions. I think most of them that are taken from the HCM, if I'm not mistaken. Sometimes I rely on the textbook that I used when I was teaching these classes. One famous book, as all of you know, is Garber and Hoyle, which is my reference. This is, they call it the Bible, okay, for traffic and highway engineering. This is a 5th edition by Garber and Hoyle. Garber and maybe you use it in school. Here it is. Oh my God! I opened it and it came to the lane groups and okay, and for analysis, which you are going to see it shortly. And this equation here, we are going to see it also. This is for the saturation from the HCM. This is saturation flow rate. Saturation flow rate, S is equal S sub O, and they multiplied by all these adjustment factors. So this is my favorite book. I use this book a lot when it was the 1st edition. Right now with the 5th and maybe the 6th on the way. Okay, the other book also, which I rely also on it, I use it also before, a traffic engineering by a group of professors, traffic engineering by Roger, okay, Elena and William. The traffic engineering, here is an intersection. This is a very well respected, this is a 5th edition also, I believe. Yeah, it is a 5th edition. And it's a very nice book. It's a very nice book. Also, I use it a lot. I use it a lot when it was the 1st edition. Also, over all these years, I use all these books. In fact, Garber and the Hoyle, here it is, by the way, the 1st edition. Here it is. It was the yellow. The traffic, and this is the yellow. This is the 1st edition. I used it way back when I was teaching in Las Cruces, New Mexico. It was not as thick as, but anyhow, whatever book you are using, whatever material you're using, as long as it will provide you with enough information to prepare for the exam. So some definitions. So it could be from HCM and textbooks. I believe a combination of both. I cannot claim that all of them came from one source. So what is all red time, which is called red clearance time? All red time, they are using the R sub C. This is a time within a cycle in which, okay, all approaches have a red indication, except this in second. Okay, this time is referred to as the clearance interval because it allows vehicles, okay, that might enter the end of the yellow interval, okay, to clear the intersection before the green phase starts on the next, okay, conflicting movement. So they call it all red, where all the approaches have the red, and this is will give enough time to any car that entered the signal at the end of the yellow. We saw the yellow and we entered the yellow. The last second of the yellow I enter. In this case, the signal will allow me to clear the intersection. And there is one equation, and there are some problems. We are going to see it later on. Indication, interval, cycle. So there is a lot of definitions here. Nobody will ask you to memorize these definitions, but we need to be. So cycle length is very, very important. Green time, what is the phase? Yellow time also, red time. All this is effective green time. Also, we are going to see the G, the effective red time, lane group, saturation flow rate, sorry, saturation flow rate, which is the we're going to see it. Okay, the saturation, which is S. Okay, S is equal S sub O times all these factors. Okay, we are going to see all these factors. If you flip the page, you will find they came up with something called typical lane groups for analysis. Okay, so this is from the HCM. Okay, so the number of lanes, 1. Okay, so left through or right. Okay, the movement group, they call it MG, and the lane group, they can go together or they can go individually. Okay, if your lane group number of lanes 2 and 3, they came up with these configurations, okay, in order to help us to decide the movement, the 7-11, and we're going to talk about this shortly. Okay, if you look to the types of movement and signal controllers, there are some movements are protected and some movement are permitted. Protected means a movement that has the right of way and does not need to yield to conflicting movements such as opposing traffic or pedestrian. So this is a protected, mean that protected movement that I have the right of way to move on. I don't like to wait until, okay, the other traffic or pedestrian, okay, to clear. Okay, through movement, okay, which always protected, okay, are given a green full, okay, circle indication. A left or right turn movement, okay, that are protected, okay, from a green arrow indication. This, okay, pointing either right or left. So if you have protected, it will be a line, okay, or an arrow to indicate right or left. This is a protected as long as it is on the signal. Okay, this is called the protected. There is another movement called permitted. This is a movement that must yield to opposing flow. You have to wait until it's clear. Okay, or if a conflict with pedestrian, you have to wait. I have to wait. So this is permitted movement. Is not protected. You are allowed to turn, but if there is a traffic, okay, pedestrian, you have to wait until the pedestrians are, okay, or if you are turning, okay, left, for example, okay, and there is a traffic coming, if you are, okay, in this case, you have to wait until you clear this. This is called permitted, okay, movement. So I need you to know the difference between them if there is a conceptual question, okay, is asked about the difference between protected movement and permitted, okay, movement. Okay, as far as the signal, okay, controllers, we talked one of them, which is the traffic, okay, actuated. We said that if the warrant, okay, if you remember the warrant number Do you remember the warrant number? Okay, just to bring it one more time. Warrant number three. Warrant number 3, which is a 1 hour. So if this warrant is the only warrant, okay, because 1 hour, because we said that this is going to be, the signal will be if this the stop sign here, and we need to figure out if there is, satisfy the warrant, because there is a shopping center here or something like that. So the 1 hour, no, wait a second. No, this is an unusual situation. Yes, this is not pedestrian. If this here, if we have the cars, sorry, okay, the drawing that I did, here it is. So if this is a warrant, okay, the peak hour signal warrant is intended for location where, okay, traffic such as 1 hour average day, okay, and this is for the high occupancy, okay, here it is, industrial complex and so on, okay, and this is the one I showed, traffic, here it is, yes. So we have bunch of cars are on the minor street waiting. So if this is that means that it has to be traffic actuated, because I need the minimum number of cars here or there to actuate, okay, the signal to make it green, so the traffic can go either this way or whatever is, okay. So this is something that related to the discussion we have here. So the traffic signal controller could be permitted or semi-actuated or fully actuated. Okay, for the permitted, okay, a signal whose timing, the cycle length green is fixed over a specified time period and does not change in response to the traffic flow at the intersection. No vehicle detection is necessarily for this mode. So there's no need for loops or any cameras or anything to detect the traffic. This is for permitted. For the semi-actuated one, that a signal whose timing, signal length and cycle length, green and so on, is affected when the vehicle is detected by a video pavement embedded, okay, and loops, okay, but not all approaches, okay. So this mode is, okay, in operation is usually, okay, found where low volume road intersects a high volume road, often referred as a minor, and this is what we're talking about. So this is the semi-actuated, is not fully actuated in this case. Okay, the fully actuated one, a signal whose timing signal is, okay, is completely influenced by the traffic volume, okay, on all approaches, in all approaches. Here we're talking about the minor, so this is the semi, the one we're talking about, okay. So I needed to know the difference between these, just in case if they ask you a conceptual question, or maybe in the problem statement they are going to throw this term and something like that. There is a question, first column maybe should be okay, pre-timed, not permitted. Okay, okay, you are okay. Pre-timed, okay, so timing, I have no, so pre-timed, thank you. Okay, I have no problem with that. I have no problem with that. It will be better word, in fact, okay. Thank you. Pre-timed will be much better word, okay. Maybe it could be a typo, I can look, but I really appreciate that. So I will look to this. Let me put a note here. Pre-timed, I think, pre-timed. And it says here when is fixed over, okay, signal timing. Thank you. Okay, double check could be corrected in the other book, and this is an older book, but pre-timed. Okay, this is a pre-timed, that a signal whose timing, okay, is fixed over the period of time. No problem. Thank you very much. Okay, or the semi-actuated or the fully actuated. Okay, so they came up with something. Okay, it's called 7-11. Okay, 7-11, the 7-11 rule, movement, timing, and phase numbering for signals. They have the ring diagram in front of us in order to ensure the safety and operation. Safety number one, obviously, they came up with the 7-11 rule, where you have a barrier here, call it a barrier, and this is a phase 1, phase 2, phase 3, phase 4, phase 5, 6, and 7, and 8. And these phases, they go together. 3 and 8, they go together. This will add 11, and 4 and 7, they go together, and 11. So this is 11 along the minor street. The phases along the major street, it is 1 and 6, sorry, they are 7, and 2 and 5 are 7. So this is, they call it the 7-11 rule, where the phases along the major street 7-11 rule. So the I explain it here just in case. I don't know if they can ask you something like that. This is, for example, the dual ring structure with illustrative of movement assignment. Okay, and showing the phases, how the phases they go together. Even on the following page, they have also, I have some big drawing here where I have a major street and a minor street, and the 7-11 rule we apply it here, where you can the a typical signal layout. Okay, the phases, if this is a major street and this is a minor street, so the 7-11, phase 1 and 6, and phase and 2 and 5. Okay, so 1 and 6, and the minor street 3 and 8. So the major, okay, the minor street, it has 11, and the major street, they have 7. So just in case I needed to look to that. If you look to the MUTCD, they have some diagrams. Okay, the traffic flow and signal. So if the this is stop line here, and this is a distance, and the green and yellow and the green, and yellow and, sorry, red and yellow and the green. Okay, so they came up with this illustration to show us as far as the traffic flow versus, okay, the distance and speed and so on, and we're going to see some. Last time, there is lost time. The lost time, there are two components of the lost time, by the way, and the equations I provided here from the HCM. Okay, so for example, the L sub T is equal L1 plus L2. What is L1? L1 is the phase lost time, and okay, L sub T, sorry, is L sub T, and L1 is a lost time due to the startup time, and the L sub 2 is a clearance time. So the lost time, the L sub T total lost time, is the L1 plus L2. The L1 here is the startup time, because you are at this intersection, or when we are at the intersection, and I am waiting, okay, for the green. Okay, so the moment that I have a complete stop, but and it turn to be green, obviously it will take some time to take my foot from the off from the brake, and put it on the gas. So there is, they call it lost time, it's called the startup time, and they assign it 2 seconds. Okay, so this is a lost time, and the second lost time is the clearance time. The clearance lost time, when all approaches are red, in order to allow the people who are entering the intersection at the last second of the yellow time. So they define this as the total lost time, which is L1 plus L2. Okay, and the clearance lost time is equal the yellow plus the RC minus E, okay, in second. And the E is extension of the effective green, which is also given as 2 seconds. So this is the equation here that is given, equation 19-1. If you flip the page, you will find there is a table that's given in the MUTCD, HCM, sorry, HCM, with some kind of variables, okay, and the symbol they are using and the definition of each one of them. I found it may be useful for you, especially for those of you who are doing a signal design or work in the traffic operations. So the green interval duration, which is G, Y, RC, which is a red clearance interval, C is a cycle, G, and so on, E, R, all these things I put it here, L1, okay, L2, LT, which is the total lost time. I found it is very so I needed to be aware of this table. Okay, the phase duration, also another equation, equation 19-2. Okay, the equation is given as the D sub B, which is the phase duration is equal these parameters here, and each one of these has been okay identified for us. Okay, so I needed to be aware of this equation. This diagram also is taken from the MUTCD, from the HCM, the highway capacity manual, which is time element, okay, elements influence, okay, actuated phase duration. I can go over it and I can explain it to you. It's not very critical, but okay. The effective green time, this is a very common, by the way, and here is the equation for the effective green time. We're using this letter G, okay, like a gravity acceleration. Okay, we need to be aware of that, and here are the parameters. If some default values are given, by the way, to you, that's fine. If not, okay, given in the problem statement, other than these, use whatever numbers they gave you. Okay, so I need you to be aware of that. The signal coordination, which one of the warrants that we talked about, sometimes they insert a signal in between two signals in order to ensure coordination. So a traffic signal time should be timed, okay, as many vehicles as possible arrive at the signal intersection when the signal is green. This will be the best. And probably some of you experience that when we hit a signal, green, 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 this is the best. They came up with this equation, which is given also, offset is equal D sub O divided by V. I believe this equation they included in the blue book, if I'm not mistaken, the chapter 5 of the PE handbook, transportation. I believe I saw it after this. Here it is, which is, here it is, yes, the offset, here it is. So this equation is given also on page 288, which is the offsets. What it is, offset is equal D sub O divided by V. This is the same equation. So this is, I needed to be aware of that, okay, because they have a problem in the NCEES. So let us read it together from, this is the handbook V1.2. So the offsets, okay, the time difference between a common reference point, okay, in the coordinated phases at adjacent signal intersection is referred to be as offset. Okay, assuming movement plateau, okay, the offset is calculated and give you these parameters here. So this is something that I need you to be aware of of the offset is equal to, you can say it here probably, this equation here, okay, which is the offset d sub o divided by v. I will say that it is page, okay, 288 of the handbook v1.2. Okay, and I define it also for you here. And I believe there was a problem, I don't know if it's still here or not, among the questions. Yeah, here it is. Yes, here it is. Problem number 69. 69, he gave you a section of a major street, an urban arterial, okay, with 6 traffic signalized intersection is shown, and they give you the bandwidth, and all these things is given. The bandwidth, we are going to talk about it, okay. This is the equation I just talked about. So if the d sub o is the distance, okay, is given to you, okay, the offset, okay, the distance from this intersection to this intersection, and v is given to be 30 mile per hour. So we need to convert the mile per hour to make it feet per second. That we can use the famous conversion 1.47, which is basically 5280 divided by 60 by 60. You remember we talked about that when we talked about the stopping side distance. So basically a simple calculation using this. If you would like to say that this is the NCEES on page 288 will be a good idea. Page 288, as always, a handbook V1.2. Try to do our best to write the references, okay, many times. Everywhere you find an equation that, okay. So this is what the offset here, and I believe I have a problem on the following page. Problem 14-1, 2 intersections, okay, on a one-way arterial are separated by this amount. The average, okay, running speed of vehicle along the segment is 40 miles per hour. So what is the necessary idle, okay, progression, okay, between the 2 intersections? I use this equation here, and if the distance is given and 40 miles per hour is given, and this is a 1.47, give me 45 seconds, and this is, okay, straightforward and easy problem. Hopefully you can find something like this on the exam. Okay, we are going to talk about this after lunch, which is a time space diagram. So we're going to meet at 1 o'clock. Okay, so now it's 12 o'clock. We're going to meet at 1 o'clock to continue this section. Okay. Okay, yeah, I think I can finish it this afternoon. Okay, enjoy your lunch. Try to make your lunch as light as you can. 250 calories is good. Thank you very much. So let us join me. Normally I end the session. I ended, okay, and I will start over again at 1 o'clock. So you can use the same ID to join me again, and we will do it our best. Okay, thank you very much. Okay, enjoy your lunch. Bye bye, everybody.